All right, welcome back to The Explainer. Today, we're stepping right into what I like to call a grand cosmic true crime story. I mean, we're looking for the ultimate missing person, or actually, scratch that, the ultimate missing substance. We are officially on the hunt for the ghost in the machine, dark matter. Let's get right into it.
Okay, so just wrap your head around this for a second. A staggering 85% of the matter in the universe is just completely missing. Think about that. Everything you've ever seen, touched, or interacted with, every single planet, every star, every massive galaxy out there, it all only adds up to that tiny 15% slice of visible matter. As for the rest of it, honestly, we have absolutely no idea what it is.
So that brings us to the obvious fundamental question, right? Where is the rest of the universe? It's wild. You kind of have to frame this massive knowledge gap in your mind as an ongoing scientific investigation, because everything we can observe with our own eyes, even with our most powerful standard telescopes, is just a tiny, tiny fraction of what's actually out there. There's this massive hidden scaffolding holding reality together, and today we're going to look at the clues it left behind.
Part 1. The cosmic crime scene and the speeding stars.
So let's look at the timeline here. This mystery really hinges on a few pivotal moments. Way back in 1687, Isaac Newton lays down the laws of gravity, basically giving us the absolute rulebook for how objects in space should behave. But fast forward to the 1970s, and astronomer Vera Rubin notices something, well, impossible. She was observing the outer edges of galaxies and realized that the stars on the very outermost rims, they were moving incredibly fast, like they were moving just as fast as the stars clustered tightly near the dense, heavy center of the galaxy.
And this discovery blew things wide open. It created what we now call the galaxy rotation problem. Here's the issue in a nutshell. According to Newton's perfectly established laws of gravity, those stars on the outer edge were just moving way too fast. There simply wasn't enough visible stuff, enough mass, in the galaxy to generate the gravity needed to hold on to them. By all accounts, they should have been flung right off into deep space, kind of like water spinning off a wet tire, but they weren't. Something completely invisible had to be holding them in place.
And this brilliantly illustrates the problem. This formula for orbital velocity right here, this is our forensic smoking gun. So, V is the star's speed, G is gravity, M is the mass inside the galaxy pulling on the star, and R is the distance from the center.
Let's just dust for fingerprints on this math for a second. On the left, you've got what we expected to happen. As a star's distance, r, gets bigger, its velocity v is supposed to drop. Makes sense, right? But look on the right. This is the reality Vera Rubin actually observed. The velocity stays totally flat. Now, if you look back at that equation, if v stays flat while r keeps getting bigger, the math literally breaks down. Unless there is a massive amount of invisible m, this invisible mass secretly balancing out the equation behind the scenes. And that invisible mass, that's exactly what we call dark matter.
Which leads us to part 2, forensics of the invisible and seeing the unseen.
Now, you might be wondering, if we can't actually see dark matter, how on earth do we map it? Well, we do it through this wild phenomenon called gravitational lensing. Basically, really massive objects physically warp the fabric of space itself, and that creates a curve that bends the path of light traveling from distant galaxies. So when astronomers look deep into space, they'll often see light warping around regions that look completely empty. The light is bending around literally nothing, which absolutely proves that a massive amount of invisible matter is sitting right there, even if light totally refuses to bounce off of it.
And honestly, the most striking proof of this is the Bullet Cluster. This is actually two massive galaxy clusters slamming into each other. The visible gas of these galaxies crashed and slowed down, literally just like a massive cosmic car crash. But when scientists used gravitational lensing to track the mass of those clusters, that massive dark matter scaffolding, it just sailed right through the crash site, didn't slow down at all. This was a huge deal because it proved, definitively, that dark matter doesn't interact with normal matter. It passes right through it, just like a ghost.
All right, part 3, the suspect lineup. Let's interrogate the candidates.
Now, what's really fascinating here is how wildly different our prime suspects actually are. First up in the lineup, we have WIMPs. That stands for Weakly Interacting Massive Particles. These guys are heavy, and if they do exist, billions of them are passing right through your body every single second without touching a single atom of you. Crazy, right? Next up are axions. Instead of being heavy, these are ultralight, behaving way more like an invisible mist or a cosmic field. And finally, we have the rebel suspect, MOND, or Modified Newtonian Dynamics. This one just throws the whole thing out and argues, hey, dark matter doesn't even exist, our math for gravity is just fundamentally wrong at a galactic scale.
Moving on to part 4, the underground stakeout, waiting for a signal.
So if you want to find something as incredibly elusive as a WIMP, you require extreme isolation. Scientists are literally building these massive detectors in places like SNOLAB in Canada or Gran Sasso in Italy. And they aren't just in basements. They're built inside old mines, literally kilometers deep beneath the Earth's surface. Why? Just to shield their ultra-delicate instruments from the constant, noisy bombardment of normal cosmic rays constantly raining down from space.
Okay, so once you're shielded deep, deep underground, here's the play. You fill these massive, super cool tanks with liquid xenon. Xenon is a super dense, noble gas, and then you just wait. The hope here is that out of the billions of dark matter particles just ghosting through the Earth right now, just one of them will accidentally bump directly into a xenon nucleus. If it actually does, it'll create this microscopic, incredibly faint flash of light. Just a tiny flash, deep underground, but that would finally unmask our ghost.
And it's just such a profound thought to end on. Think about the scale of this. We jump from the macro scale of the entire visible universe spinning way too fast, all the way down to waiting for a microscopic flash in a tank of liquid xenon buried deep inside a mine. The math and the forensic evidence confidently tell us the ghost is out there in the machine. In fact, it makes up most of our universe. But as our global underground stakeout continues, the ultimate question remains: will we ever actually catch it? Thank you so much for exploring this incredible cosmic mystery with me today. Stay curious, keep looking closely at the data, and I'll catch you in the next explainer.